All right, hey everybody. I am working in a textbook today. We're doing activity 4.2 on page M1-57. And so what we're going to be doing is looking at functions and trying to see what function rule matches our graph. So the first thing I would do when I approach this problem is look at the concavity. When we're looking at whether this is concave up or down, we see that the function is indeed going down. So that means the leading coefficient, or the a value, has to be negative. So since this has a leading coefficient of -2, that could be it. We don't want to rule that out yet. But like function 3, we can absolutely cross that out. We know that the leading coefficient needs to be negative, not positive. This one is positive, not good. This one is also positive, so we can rule it out. Negative, that's what we're looking for. And then both our functions on the bottom are negative, which mean that they are concave down. So now let's look at each function individually. So function number 1, it's giving us factored form, and it's also giving us, it's giving us solutions to it. It's giving us x-intercepts. We've got one x-intercept at -1. This one is -4. It's telling us we cross the x-axis at -1 and at -4. So I would assume that -1 would be like right here, maybe -4 here or something, but we're not going to rule this out because it doesn't actually give us a scale or like tick marks that we're going by on either axis. So let's go ahead and say that that one is possible. That one could be our function rule. Again, just because we don't have enough to really rule it out. So that could be it. This next one, it is in standard form. And all its standard form is going to tell you right off the bat is the y-intercept. The y-intercept is at 0, -6. It's telling us we're going to cross the y-axis at -6. This is another one where we don't really have enough information to absolutely rule it out. The function could keep going down and cross this y-axis at -6. It's possible. So we'll go ahead and box that one too. We could also test the axis of symmetry, but I don't want to go that far in this video. All right, so the next function that we're going to look at is number 6. So hey, this one is in vertex form. It's actually just going to tell us the vertex just by looking at it. So remember, the vertex is a point, and it's telling us that this point is at +6, +3. So on the graph, that means I'm going 6 to the right and then 3 units up, getting somewhere around here, which is definitely not true. I go to the left for my x values. I don't go to the right. Function number 7, this is another one that's in factored form, kind of like this first one that we did up here. And it's saying that we have solutions at -2 and at -3. Not -3, +3. So -2, sure, that could be possible, maybe right here. But it's telling us we cross the x-axis also at a positive value, maybe like right here. Since we don't cross on the positive side of our x values, that cannot be the function. All right, our last function, another vertex form. This is telling us, this one right here is telling us that we have a vertex at -6, +3. So that certainly seems to be true. Again, we don't have axes to really test this out, but it appears possible that we could go 6 units to the left and 3 units up to get to this vertex. So let's go ahead and put a box around that one as well. So if you did the assignment about key features, you're probably going to be doing pretty well with all of this stuff. So with that said, let's move on. Part B, another function. Again, I think the best thing to look for right off the bat is concavity. So this one's concave up, which means we can get rid of any function with a negative leading coefficient. It cannot be this. Can't be this. Function 4, we don't want negative coefficients this time. and it looks like those are the only two with negative a values. All right, so let's go through each function individually now. This one is in vertex form. You can tell by the square around the one parenthesis, and the vertex for this one is at 75, negative 92. So hey, that appears to be possible. I can go over 75 and down to 92. Again, we don't know what the scale is, so we can't say for certain, but it has the right idea. It has the vertex in the right quadrant, at least. Now this one, in factored form, gives us an x value of positive 8 and an x value of negative 2. So we do have one positive x-intercept, but we never go here. We're never in the negative x range, or never intercepts the x-axis at a negative value, so this cannot be our function. This one, it's in standard form, so it gives us the y-intercept, and the y-intercept that it's giving us is 240. And that appears to be true. It could eventually cross the x-axis at 240. So we'll say this one is plausible, could be true. Now this one in standard form, it's saying that the y-intercept, just given by this number on the end, it's saying that the y-intercept is at negative 2. It's saying we're going to cross somewhere down here. That is certainly not true. We know the y-intercept is going to be a positive value. It's going to cross somewhere in the positive range, so that cannot be our function rule. Moving on, we've got another vertex form. This vertex is at negative 4, negative 2. We do not go left 4, down 2 to get to the vertex. We would have to go to the right to get to our vertex. So this can't be it. That cannot be our function. And the last one, it gives us two solutions, or x-intercepts. It gives us x-intercepts of negative 1 and negative 3. So if these signs were reversed, then it probably could have worked. Positive 3, positive 1. But we do not cross at negative 1, negative 3. Our x-intercepts are positive values. So that also cannot be our function rule. Okay, we have one more of these to go through. I'll walk you through it on the next page. This will be M1-59. Okay, part C. Got another function here. So unfortunately, on this one, it's concave up, but I am not seeing any negative coefficients. So we'll have to go through these individually. All right, so this first one, another thing to really pay attention to, you see how we don't have any x-intercepts? There are no x-intercepts. No x-intercepts. So this function is telling us that we cross the x-axis at negative 1 and at 5, but we don't cross the x-axis at all. So that cannot be our function rule. This one is in vertex form, giving us a vertex of negative 6, negative 5. So this negative 6, negative 5, definitely not. The vertex is not in quadrant 3 down here. All right, standard form, giving us a y-intercept of 0, 10,000, 10. Put a 0 there. So I guess that could be true. You know, the function keeps increasing, and it could eventually cross this y-axis at 10,000, 10. It could eventually do that. So let's just go ahead and say that this one could be true. All right. Number 4, we've already established we don't have any real solutions here, no x-intercepts, so this cannot be our function. This one is in vertex form. It's saying a vertex is at positive 6, positive 5. So that means you go 6 to the right and then 5 units up. So this one has the right idea. Just to reiterate one more time, we don't have scales, so we can't say for sure. Function 6, this is in standard form, and it's saying the y-intercept is at negative 5. We don't even go below the x-axis at all, so the y-intercept cannot be negative 5. Never going to go below the x-axis, so that cannot be our function rule. Okay, that just about does it. Number 2 here is just identify which form these are. Very important to be able to do that. We'll just kind of not worry about the second part of the question, but that first part, just by looking at this, you should know that it is in factored form. That is factored. This one, just by looking at it, vertex form. And then for the conversion part, it's something that we practice a lot in the first topic. It's just multiplying these things. You'll multiply x plus 1 by x plus 4, and then distribute the -2, or however you prefer to work through it. Vertex form, remember you would just rewrite x minus 6 squared as x minus 6 times x minus 6, and then simplify, and you can get to standard form. So anyhow, that is going to do it for this video. I appreciate y'all watching. Thank you, bye.